In the last section, or sections in 6.5 and 6.6, we were working with circumference. We're going to finish the unit with talking about a portion of the circumference called the arc length. So remember, we had arc measure throughout this unit. We talked about the arc measure. That's the degree measure of an arc is equal to the measure of the central angle that intercepts the arc. So in other words, a circle is 360 degrees around. Parts of that rotation around would be called the arc measure. So for instance, in this problem down here, the arc measure is 90 degrees because the central angle is 90 degrees. So arc measure, and maybe I should put that in red since that's what the definition is up above. So arc measure there is 90 degrees. So it's a part of the 360 degree rotation all the way around the circle. Now arc length is a length measurement. So it's a fraction of the circumference of the circle. So arc length in a circle, the length of an arc is the portion of the circumference. So although this is 90 degrees in measure, what I want to know is how long is that distance along the arc and how far is that from A to B. So we're going to do a little investigation first just to make this hopefully more clear. The first set of questions are, find what fraction of the circle each arc is and write it below. So we talked about we had 90 degrees on our first problem here, and that was out of 360 degrees. So 90 degrees out of 360 degrees. What fraction is that? Well, that would be 1/4 of the circle. So reducing that, 1/4. That is our fraction there. And the second one, we're looking at this arc here, CE to D. And again, we're looking at what fraction of the circle is that? Well, that's 180 degrees because it's a semicircle. And therefore, 180 out of 360 is equal to 1/2. So that's 1/2 of the circle. And then in the last one on the part C here, we're looking at the arc measure of 140 degrees. So we're looking at this arc here between G and H. That's 140 degrees. So again, 140 out of 360. That's not quite as nice of a fraction, but if you reduce that, 20 goes into 147 times, 20 goes into 360 18 times. So that's 7/18 of the way around the circle. All right, now let's go and find the circumference of a circle. We know circumference is pi times diameter, or 2 times pi times radius. So in this first one, circumference 2 times pi times the radius of 12. So 2 times pi times 12 meters would be a total of 24 pi meters. Okay, so the circumference on the first one is 24 pi meters. You can multiply 24 times pi and get a decimal, but we're going to keep it exact for this problem. The second one, we have the diameter here is 4 plus 4, which would be 8. So let's use that version of our circumference. Circumference is 2 times pi times radius, or pi times diameter, or diameter times pi. So in this case, that would come out to 8 pi, in this case, inches. And then in part C here, we have a circumference, which, since we have the radius of 36 feet, let's go back to our radius version of the circumference formula, 2 times pi times radius. So that would be 2 times pi times 36, which is 72 pi, and in this case, feet. So those are the circumferences associated with each one of the circles. So now if we just think of how we could combine those two together, the fraction of the circle and the circumference, well, if you think back to what we were doing here, what we really are interested in part A is 1/4 of the entire circumference. So the 1/4 is the fraction of the circle that we're looking at, and we don't want the entire circumference, we just want 90 degrees of it, in other words, 1/4 of it. So we want 1/4 of 24 pi. So you can either divide 24 by 4 or take 1/4 times 24 pi. And if you're multiplying fractions, then that would be 24 pi over 4. 1/4 of 24 is 6 pi. So 6 pi meters. All right. Now at this point, since we're finished, I'll give you a decimal approximation as well. So that's about 18.8 meters. All right, part B, same idea. We want to take 180 degrees of the entire circle. So in other words, half of the circumference here. So that arc length is half the circumference. So 1/2 of the circumference, 8 pi inches. So 1/2 of 8 pi would be 4 pi inches, which is approximately 12.6 inches, 12 and 6/10 inches. So that would be that arc length, about 12.6 inches, or exactly 4 pi. And then the last one, we have 7/18 of the circumference. So 7/18 of 72 pi. Now, this particular one might involve a little bit of fraction work for you. I'm just going to do the work off on the side over here. So if you're multiplying fractions, and you can use your calculator for this if you want, but what you can do is multiply 7/18 times 72, which you can multiply straight across when you're multiplying fractions, or you can kind of reduce along the way. So diagonally here, I can reduce. I can see, all right, 18 goes into 72 4 times. 18 goes into 18 1 time. Is there anything else that can be reduced in the numerator or denominator? Doesn't look like it, so now we can multiply across. 7 times 4 is 28. 1 times 1 on the bottom is 1. All right, so if we multiply these two together, 7/18 times 72 pi would be 28 pi, and that is feet, which is approximately equal to, about 88 feet. For rounding, that actually, I think it rounds to the nearest tenth, which gets you to the nearest whole number on that one. So those are our arc lengths. So if you think about arc length, it's just the fraction of the circumference that you're working with. So if we think about the conjecture down here, arc length, I'm just going to put the whole formula in here. So arc length is equal to basically our arc measure, so the degree amount of the arc, out of 360. So if it was 90 degrees, like we did up here, 90 out of 360, or 1/4. If it was 180 degrees here, 180 out of 360, which would be 1/2. So we took that was our number one, and then we multiplied it times the circumference, because we're interested in what fraction of the circumference. So circumference, at least in its diameter form, that would be pi times diameter. So basically, we're taking the fraction of the circle that we're talking about, and we're multiplying it by the circumference. So the fraction of the circumference is really what we are looking at here. All right, so let's say I take a little circle here. Maybe I can quickly get one drawn up here. Let's see, circle. All right, so let's say that's my circle. Let's say that's about where the center is, right there. Let's draw a radius and a radius. Let's say this is n degrees for the central angle there, so n degrees. And I want to know what my arc length is. So I want to know what that arc length is. Basically, that means I'm going to take n degrees out of 360 degrees times whatever the circumference is, which I'll abbreviate because I'm running out of space here. So fraction of the circle times the circumference will equal our arc length.